So welcome, this is CII May June 2009, paper 3, pure mathematics 3 paper. There are something around 10 questions, but one question is from vectors, which is moved to further maths. So therefore we are not doing that one. So let us start with solve the equation. First question, the solve the equation ln2 plus e power minus x is equal to 2, giving your answers in two decimal places. So let me change the plan of the grid. So first question, ln 2 plus e power minus x equals to 2. So 2 plus e power minus x is equal to e square. So it becomes as e square. Then e power minus x is equal to e square minus 2. So I want the value of x over there. So what am I going to do? I am applying ln on both sides. Ln e power minus x is equal to ln e square minus 2. So minus x comes front. Minus x ln e is equal to ln e square minus 2. So ln e is 1. So minus x is equal to ln e square minus 2. So x is equal to minus ln e square minus 2. So when I do that by calculator and get it out, the answer in three significant figures, answer is minus 1.68. So that's going to be the answer for the first question, which is ln e square minus 2 whole minus is minus 1.68. That's the first question. Coming to the second question, the diagram shows the curve y is equal to square root of 1 plus 2 tan square x. X lies between 0 to pi by 4. Use a trapezium rule with 3 intervals to estimate the values. So I have to find the trapezium rule for that one. So the lower limit is called as a, the upper limit is called as b, and h, what is this, n is the number of intervals. And over here it has been given as 3 intervals. So formula for h is b minus a upon n. So pi upon 4 minus 0 upon 3, which is going to be pi upon 12. So h is pi upon 12. So what am I going to do? I'm going to formulate a table. I'm drawing the table with the values. So 3 intervals should be there. X and y starting from 0, the lower limit, and add pi upon 12 to that. 0 plus pi upon 12 is pi upon 12. Pi upon 12 plus pi upon 12 is nothing but what? 2 pi upon 12, which is pi upon 6. 2 pi upon 12 plus pi upon 12 is 3 pi upon 12. So I can write like this: 2 pi upon 12 and 3 pi upon 12. But we know that 2 pi upon 12 is nothing but what? Pi upon 6. And 3 pi upon 12 is nothing but what? Pi upon 4. Once I reach the upper limit, stop that. Now plug in these values of x in that one. So what was the function? F of x is equal to square root of 1 plus 2 tan square x. So when I plug in 0, so I'm going to get it out. Square root of 1 plus 0, which is 1. When I'm plugging f of pi upon 12, so which will be square root of 1 plus 2 tan square pi upon 12. Use the calculator, get the answer. It should be 1.069389, then 1.069389. I quickly add a page over there. Now next I substitute f of pi upon 6, so which is square root of 1 plus 2 tan square pi upon 6. I use a calculator, I get 1.290994. I write it there, 1.290994. And finally, f of pi upon 4, square root of 1 plus 2 tan square pi upon 4, which gives me 1.732050. 1.732050. So those are the values. Now, what are these values? values can be written as y0, y1, y2, y3. Now what is he asking? Use the trapezium rule with 3 intervals. So the area will be integral of 0 to pi upon 4 square root of 1 plus 2 tan square x will be h upon 2 first term plus last term y0 plus what is the last term y3 plus twice of sum of the remaining terms y1 plus y2. So it's going to be pi upon 12 upon 2. First term is 1. The last term is 1.732050 plus 2 times of sum of the remaining terms. What are the other two remaining terms? 1.069389 plus 1.290994. Do this one by calculator. I'll quickly take the calculator and again pi upon 12 divided by 2, then times what am I going to do? 1 plus 1.732050 plus 2 times of 1.069389 plus 1.290994, and I simplify that one and I should be getting it out the answer as 0.975555, but easy asking in 2 decimal places, so it is in 2 decimal places, so my answer should be 0.98. That's going to be the answer for the first part. Second part, the estimate found in part 1 is denoted by E. Explain without further calculation whether another estimate found using trapezium rule with 6 integrals would be greater than E or less than E without doing anything. So we have to take it out. So let me take the diagram. So basically I have done what I'll do is I'll copy the diagram in the next page. One time and 2 times. With the 3 intervals and 4 intervals, 6 intervals. Okay, so with the 3 intervals, I'm drawing 3 trapezius. 1, 2. This is the second one and the third one. So it is 0, pi by 12, pi by 6, and pi by 4. What am I going to do? I am going to convert into a trapezium. So I have to draw like that. Now when I'm going to draw it out in 6 trapeziums. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. This may not be equally spaced, so we try to space them equally. I'm drawing there. 1, 2, 3 done, 4 done, 5 and 6 done. Now what am I doing? I'm drawing the completing the trapeziums. I'm drawing the straight lines, you can see. Perfectly. What is this? Trying, because this is not that much perfect required. You need to just understand the concept. So I'm drawing completing the trapeziums. Whereas in this case, the blue one, I go back and draw it out again. It's not coming exact. Now you can see that when I magnify and see that, what is happening is, in case of the blue trapeziums, you can see that some extra area has been calculated. This extra area has been calculated. That area is extra. Whereas when in this pink color trapezium, so the sixth one, there is no such extra. So what we can say that is, this estimate, the second estimate, this if this is E, the second estimate will be less than E. That extra area is not being visible in the, what is this, in the second one when we can draw it out carefully. So you can see that there is no extra, what we call it as area that has been coming into because of this what is this trapeziums. So we can write that the second estimate would be less than E. Coming to the third question, prove that the identity is this much. Cosecant 2 theta can be written as 1 upon sine 2 theta. Cot 2 theta is nothing but what? Cos 2 theta upon sine 2 theta. The common denominator is sine 2 theta. So 1 plus cos 2 theta. Cos 2 theta is nothing but what? 1 minus 2 sine square theta. I want in the form of cot 2 theta. So it can be written as 2 cos square theta minus 1. Sine 2 theta is 2 sine theta cos theta. 1 gets cancelled, so I get it as 2 cos square theta upon 2 sine theta cos theta. Then 2 cos theta gets cancelled, 2 and 2 gets cancelled, 1 cos theta gets cancelled. Cos theta upon sine theta, which is equal to cot theta. That's going to be the answer. Now hence solve the equation equal to 2 lying between 0 to 360. So we have to solve that equation. So I add a page over here. So cot theta equal to what has been given, cosecant 2 theta plus cot 2 theta is equal to 2. Cosecant 2 theta plus cot 2 theta is equal to 2. Just now we have proved that this one is equal to cot theta. Cot theta is equal to 2 and theta lies between 0 to 360 degrees. So cot theta equal to 2 means tan theta equal to 1 upon 2. So theta is equal to tan inverse 1 upon 2. Theta equal to tan inverse 1 upon 2. When I do that one, I get it as 26.6 degrees, but it lies between 0 to 360. General solution, if you remember or you follow my videos, general solution for tan will be n pi plus alpha. No need of drawing any unit circle method. This is the easiest method, n pi plus alpha. So theta is equal to n pi plus, this is alpha. Alpha is 26.6 degrees. So substitute n is equal to 0. So you get it out 0 plus 26.6, which is 26.6 degrees, which is still in between 0 to 360. N is equal to 1. We get 180 plus 26.6, which is 206.6 degrees. So it is still between 0 to 180 in 0 to 360. N is equal to 2 becomes 2 times pi. Pi is 180. This was 1 times pi and 2 times pi plus 26.6, which becomes 386.6 degrees, which is more than 360 degrees. So therefore my answers are 26.6 degrees and 386 is not being considered. 206.6 degrees, that's going to be the answer. Coming to question number 4, the equation x cube minus 2x minus 2 has one real root. Show by calculation that this root lies between x is equal to 1 and x is equal to 2. So what am I going to try? I am trying to let f of x is equal to x cube minus 2x minus 2. So I am going to try f of 1, which becomes 1 cube minus 2 times 1 minus 2, which is 1 minus 2 minus 2, which is minus 3. Then I'm going to try f of 2, which is 2 cube minus 2 times 2 minus 2, 8 minus 4 minus 2, which is 2. We can see that as f of 1 and f of 2 are having opposite signs. Opposite signs, root lies between Root lies between 1 and 2. Root lies between 1 and 2. That's the first part. Second part, prove that if a sequence of values is given by this iterative formula, it converges to this root. So what was that iterative formula? X, I start in this page itself only. X n plus 1 equal to 2xn cube plus 2 upon 3xn square minus 2. So remove all those subscripts, just write x equal to 2x cube plus 2 upon 3x square minus 2. Then do the cross multiplication. It becomes x times 3x square minus 2 is equal to 2x cube plus 2. So it becomes 3x cube minus 2x is equal to 2x cube plus 2. Bring all the terms on one side. 3x cube minus 2x minus 2x cube minus 2 is equal to 0. So it becomes x cube minus 2x minus 2 is equal to 0. So which is our main equation. Use this iterative formula to calculate the root to 2 decimal places. Give the result of each iteration to 4 decimal places. Use this iterative formula to calculate the root to 2 decimal places. So the iterative formula was xn plus 1 is equal to 2xn cube minus or plus 2 divided by 3xn square minus 2. So what am I doing? We know that the root lies between 1 and 2. So I start with 1. X0 is equal to 1. So let n is equal to 0. So it becomes x0 plus 1 is equal to 2x0 square plus 2 upon 3xn square, x0 square minus 2. So which is 2 times 1 square plus 2 upon 3 times 1 square minus 2. Which I do that, I take the calculator. 2 times 1 square plus 2 divided by 3 times 1 square minus 2, which gives me 4. Next, what am I going to do? I am going to take n is equal to 1. So x1 plus 1 is equal to 2x1 square plus 2 upon 3x1 square minus 2. So x1 value was 4 whole square plus 2 upon, this was whole cube, right? The first one was whole cube. So let us make a small correction. In case of first one, there is no change if at all it is cube, but in the second one onwards, there will be a lot of change if at all it is whole cube or whole square. So whole cube, 4 square minus 2. So I go back and change to whole cube and also the values to 4. So what does that becomes? When I have changed it out, it becomes 0. I have changed to this one, so it becomes 2.838260. Each iteration to how many places he said? Indeed, each iteration to 4 places of decimal, so 2.861. Now I take n is equal to 2, so x is equal to 2 plus 1, which is 2x2 cube plus 2 upon 3x2 square minus 2. So 2 times 2.8261 whole cube plus 2 divided by 3 times 2.8261 whole square minus 2. So I go back and change the values to 2.8261 and delete that 8, 4 and write 2.8261. So it becomes 2.1467. Then I add a page. Then n is equal to 3, x is equal to 3 plus 1. So 2 times x3 square plus x3 cube plus 2 upon 3x2 square minus 2, 2.1467 whole cube plus 2 divided by 3 times 2.1467 whole square minus 2. So it is 1467, 1467. So it becomes 1.8423. Then I go for n is equal to 4, x4 plus 1 is equal to 2x4 cube plus 2 upon 3x4 square minus 2. So 2 times 1.8423 whole cube plus 2 upon 3 times 1.8423 whole square minus 2. So I go back and change in that calculator 1.8423 both in the numerator and denominator. This value is 1.8423 has to be changed. So I get 1.7728. Now I will try one more time. N is equal to 5. 5 plus 1 is equal to 2x5 cube plus 2 upon 3x5 square minus 2. So 2.1.7728 whole cube plus 2 by 3 times 1.7728 whole square minus 2. 1.7728 becomes 1.7693. So I stop it over here. Why do I stop it out over here? You can see that final answer is asking in 2 decimal places. So when I round it out to 2 decimal places, this will become 2.83. When I round it out to 2 decimal places, 2.15. When I round it out to 2 decimal places, 1.84. When I round it off to 2 decimal places, 1.77. When I round it off to 2 decimal places, 1.77. You can see that 1.77 is repeating. Therefore, the root is 1.77. That's going to be the answer. Question number 5. When 1 plus 2x times 1 plus ax whole to the power of 2 by 3, where a is a constant, is expanded in ascending powers of x, the coefficient of the term x is 0. Find the value of a. So the coefficient of x is 0. Find the value of a. So 1 plus 2x, this is a plus nx plus n times n minus 1 times x square. I don't do that one because the thing is I don't want x square. I want only x terms. So how can I get x terms? When 1 is multiplied this with term and 2x is multiplied with the constant over there. So 1 times the coefficients, 1 times 2 upon 3 times a gives me x, or 2 times 1 gives me x. This should be equal to 0 because the coefficient is 0. So 2a upon 3 plus 2 is equal to 0. So 2a upon 3 equal to negative 2, 2a equal to negative 6. So a is equal to negative 3. So a is equal to minus 3. Now what am I going to do? I am going to take that a value minus 3 because for the second part he's asking when a has this value, find the term of x cube. So when I plug in that a value as minus 3, I have done it out. The expansion I have done that one. I use the formula. 1 plus 2x times 1 plus ax whole to the power of 2 by 3, where a is a constant, is expanded in ascending powers of x. The coefficient of the term x is 0. Find the value of a. So I go for n is equal to 4, x4 plus 1 is equal to 2x4 cube plus 2 upon What was the formula? 1 plus nx plus n times n minus 1 upon 2 factorial x square plus n times n minus 1 times n minus 2 by 3 factorial x cube, and so on. I've done that expansion and I then got this one, and he's asking us to find the coefficient of x cube. So when is that possible? When 1 is multiplied with negative 4 upon 3, or else 2 is multiplied with negative x squared, 2x. So 2 times negative 1. So it becomes negative 4 upon 3, negative 2, which is negative 4, negative 6 upon 3. So negative 10 upon 3 is going to be the coefficient. Coming to sixth question, the parametric equations of the curve are x is equal to a cos cube t, y is equal to a sin cube t, express dy by dx in terms of t. So I'm going to find dx upon dt, which is a 3 cos square t, and cos t derivative is minus sin t. Then I'm going to find dy by dt, a 3 sin square t, sin t derivative is nothing but cos t. I want dy by dx. Dy by dx will be dy by dt upon dx upon dt. Dy by dt is 3a sin square t cos t divided by minus 3a cos square t sin t. Then I can cancel 3a, 1 cos and 1 cos gets cancelled, 1 sin and 1 sin gets cancelled, sin t upon cos t. Sin t upon cos t, which is nothing but what I get. He's asking express dy by dt, which is nothing but what? Tan t minus tan t. Show that the equation of the tangent to the curve at this point is this much. So equation of a tangent means this is a slope, minus tan t is a slope. So equation of the tangent will be y minus y1, which is a sine cube t, is equal to m. M is minus sine t upon cos t times x minus x1, a cos cube t. So I do the cross multiplication. Y cos t minus a sine cube t cos t is equal to minus x sine t plus a cos cube t sine t. So bring all the terms on one side. So it becomes x sine t plus y cos t is equal to a cos cube t sine t plus a sine cube t cos t. So it becomes x sine t plus y cos t is equal to a sine t cos t common. It becomes cos square t plus sine square t. Cos square t plus sine square t is 1. So my final answer is x sine t plus y cos t is equal to a sine t cos t. This is going to be the answer. Hence show that if this tangent meets x-axis at x and y-axis at y, then the length of xy is always a. This meets x-axis. X-axis means y is equal to 0. So substitute y is equal to 0. So x sine t plus 0 is equal to a sine t cos t. Sine t cancels. X is equal to a cos t. So the point is a cos t comma 0. And it meets y-axis. Y-axis means x is equal to 0. So 0 plus y cos t is equal to a sine t cos t. Cos t gets cancelled. So y is equal to a sine t. So the point is y a 0 comma a sine t. So now the distance xy. Xy will be square root of x2 minus x1 whole square plus y2 minus y1 whole square. So it becomes a square cos square t plus a square sin square t. So which will become square root of a square common cos square t plus sin square t. Cos square t plus sin square t is 1. A square times 1, which is square root of a square, which becomes a. Now coming to question number 7. Solve the equation z square plus 2 root 3 iz minus 4 is equal to 0, giving your answers in the form of x plus iy. So z equal to minus b plus or minus square root of b square 2 root 3 whole square minus 4ac, 4 times 1 times minus 4 upon 2a. So it becomes minus 2 root 3 plus or minus square root of, this is 12 square plus 16 upon 2. So minus 2 root 3 plus or minus square root of minus 12 square plus 12 square is minus 12 plus 16 upon 2. 16 minus 12 is 4, square root of 4 is 2 upon 2. So you can take 2 common and cancel it out, minus I root 3 plus or minus 1 divided by 2. So it becomes minus I root 3 plus or minus 1. So I get the two values. What is one value? 1 minus I root 3 or minus 1 minus I root 3. That's going to be the answer. So we got the values of the roots as minus 1 minus I root 3 and 1 minus I root 3. Then sketch an Argand diagram showing these points and representing the roots. So I draw an Argand diagram. One minus 1 root 3 and minus root 3. So the first one is 1 minus I root 3, 1 minus I root 3, and the next one is minus 1 minus I root 3. So I draw a proper diagram. Y-axis and the x-axis. Origin 1 minus 1, and this will be positive 1, and this will be negative 1, and this will be 2, and this is negative 2. Then 1 plus, so the roots are 1 comma minus root 3 and minus 1 comma minus root 3. So 1 comma root 3 maybe comes over here. Let it be a or z1, and negative 1 comma negative root 3, 1 comma negative root 3. This is z1 over here, and negative 1 comma negative root 3. This is z2 over here. Those are the 2 points. Find the modulus and argument of each root. So this is z1 and this is z2. So z1 is equal to 1 comma minus root 3 or 1 minus I root 3. So modulus of z1 will become square root of 1 square minus root 3 whole square, which is 1 plus 3, which is square root of 4, which is 2. Argument of that one. So argument means angle with the positive x-axis. So tan theta is equal to root 3 upon 1, which it implies theta is equal to tan inverse of root 3, which is 60 degrees, but it should be there with the positive x-axis, so it should going to be minus pi upon 3. Now coming to z2, which is minus 1 minus root 3, so modulus of z2 will be square root of minus 1 square plus minus root 3 whole square, which is 1 plus 3, which is square root of 4, which is 2. Now it is in third quadrant. So same, tan theta equal to root 3 upon 1. It implies theta is equal to tan inverse of root 3, which is pi by 3. But it is in third quadrant, so therefore I do pi minus pi by 3, and I do what it says minus of that one, because I want with positive x-axis. I want this particular angle. So what am I going to do? I am going to find pi minus pi by 3, and but I'm going in the opposite direction, therefore minus. So it becomes minus 2 pi by 3. That's going to be the answer. Now show that the origin and the points representing the roots form an equilateral triangle. He is asking us to prove that they form an equilateral triangle. So how is that it forms an equilateral triangle? So I draw that one neatly once again, and this is one line, this is another line, and this is a line. So we can see that the distance between the modulus of z1 was 2, and the modulus of z2 was also 2, and we know that the angles are, this angle is 60 degrees and this angle is 60 degrees. We know that its total is 180 degrees, so the remaining angle has to be 60 degrees. So one of the angle is 60 degrees and two sides are 2. So if the two sides are equal, the other two angles also will be equal. So this is 60 degrees and this is 60 degrees. So as all angles are 60 degrees, therefore it's going to be an equilateral triangle. Need not find the distance between z1 and z2 directly. We can just prove that as all angles are 60 degrees, it is an equilateral triangle. That is the answer for part 3. Part 4. That's right, only one mark. Prove that all angles are 60 degrees. Question number 8. Do this in partial fractions. So 100 upon x squared times 10 minus x is equal to a upon x plus b upon x squared plus c upon 10 minus x. So it becomes 100 is equal to a times x times 10 minus x plus b times 10 minus x plus c times x squared. So plug in x is equal to 0. So 100 is equal to b times 10. All other terms will become 0. B is equal to 10. Then plug in x is equal to 10. 100 is equal to c times 10 square. So c is equal to 1. Then comparing the coefficients of x square. Coefficient of x square. So 0 is equal to minus a plus c. So c is equal to a. So a is also equal to 1. So what will be my partial fractions will become 1 upon x plus b upon x square plus c upon 10 minus x. Given that x is equal to 1 when t is equal to 0, solve the differential equation. This one dx upon dt is equal to x square upon 100 10 minus x. Dx upon dt is equal to x square upon 100 10 minus x. So dx upon x square times 10 minus x is equal to 1 upon 100 dt. Now we can bring this 100 also to the other side, so it becomes 100 upon x square times 10 minus x dx is equal to dt. Apply integral on both sides. So integral of dt is t, and integral of, this is the partial fraction just now we have done, which is 1 upon x, 10 upon x square, and 1 upon 10 minus x dx. The partial fractions has been done. Then t and the, what is this, t is equal to 1 upon x integral is ln x. This is minus 10 upon x, and it becomes ln 10 minus x upon minus 1 plus c. But what is that? When x is equal to 1, t is equal to 0. X is equal to 1, t equal to 0. So 0 is equal to ln 1 minus 10 upon 1 minus ln 10 minus 1, which is 9, plus c. So I get 0 is equal to ln 1 is 0 minus 9 minus ln 9 plus c. So c is equal to 9 plus ln 9. So what is my final answer? T is equal to ln x minus 10 upon x minus ln 10 minus x plus 9 plus ln 9. 10 upon 1 is, 10 upon 1 is 10. So this is not 9, that is 10. So if I want to simplify it further, all the ln terms on one side, all the ln terms to be grouped together, so it's 9x upon 10 minus x plus 10 minus 10 upon x. That's going to be the answer. Lastly, question number 10. The diagram shows y is equal to x squared square root of 1 minus x squared and its maximum point m. Find the exact value of m. So maximum point, find dy by dx. So x square, square root of this one is 1 minus x square whole to the power of 1 by 2 minus 1 upon, so n times, so square root of, it is square root of, it can be written as basically x square 1 minus x square whole to the power of 1 upon 2. So its derivative is x square 1 upon 2 as it is, 1 minus x square whole to the power of 1 by 2 minus 1 times minus 2x plus square root of 1 minus x square as it is, x square derivative is 2x. I have used the product rule. Then 2 gets cancelled, so it becomes x cube minus x cube upon square root of 1 minus x square plus 2x square root of 1 minus x square. This should be equal to 0. So 0 is equal to, make the common denominator 1 minus x square minus x cube plus 2x times 1 minus x square. By cross multiplication, it becomes 1 minus x square. So I get 0 is equal to minus x cube plus 2x minus 2x cube. So 3x cube is equal to 2x. 3x square is equal to 2. 1x gets cancels. X square is equal to 2 upon 3. X is equal to square root of 2 upon 3. Show by means of substitution x is equal to sine theta. Show that the area of the shaded region between the curve and the x-axis is given by 1 upon 4, 0 to pi by 2 sine square 2 theta. Area of the shaded region. And substitute x is equal to sine theta. Area is nothing but what? Integral. Integral from where to where? From 0 to pi by 2. This point is, he himself told that it is between 0 to pi by 2, and x square square root of 1 minus x square dx. And what is the substitution has to be used? X is equal to sine theta. I use a substitution, x is equal to sine theta. So dx upon d theta is equal to sine theta derivative is cos theta. Now the limits of, first of all, we have to find the limits. The limits may not be 0 to pi by 2. So what are the limits from this function? So what am I going to do? This value of x is 0, that is for sure, and this value we have to find it out. So we have to find the limits. Where does it intersect the x-axis? X square square root of 1 minus x square should be equal to, is equal to y. So y is equal to 0. So 0 is equal to x square times square root of 1 minus x square. So either x square is equal to 0 or 1 minus x square is equal to 0. So either x is equal to 0 or 1 minus x square is equal to 0. So x is equal to positive 1. X square is equal to 1. X is equal to positive 1. So the limits will be 0 to 1. So thou convert that limits into x limits. So over here, lower limit is x is equal to 0. So 0 is equal to sine theta, which is theta is equal to 0. Upper limit 1 is equal to sine theta. So theta is equal to pi by 2. So now plug in 0 to pi by 2 x square. X square is sine square theta. Square root of 1 minus x square sine square theta. Dx is nothing but what? Cos theta d theta. So it becomes 0 to pi upon 2 sine square theta. Square root of 1 minus cos square theta is cos square. 1 minus sine square theta is cos square theta. Cos theta d theta. So it becomes 0 to pi by 2 sine square theta cos theta d theta. So 0 to pi by 2 sine square theta cos square theta d theta. So what am I going to do? Multiply and divide by 4. Why should I multiply and divide by 4? So that it becomes 2 sine theta cos theta whole square. 2 sine theta cos theta is sine 2 theta. So 0 to pi by 2 sine 2 theta whole square, which is sine 2 theta whole square is sine square 2 theta. So 1 upon 4, 0 to pi by 2 sine square 2 theta d theta. That is has been proved. Hence obtain the exact value of this one. So we have to find now the integration of this one. So it becomes 1 upon 4, 0 to pi by 2, 1 minus cos 4 theta upon 2, the formula. Sine square 2 theta is 1 minus cos 4 theta upon 2. So 1 upon 8. So how could I able to get that one? Use this formula. Sine square theta is 1 minus cos 2 theta upon 2, and cos square theta is 1 plus cos 2 theta upon 2. So now the angle was 2 theta, so it became twice of that angle. You can see if theta is there, it becomes 2 theta. Theta is there, it becomes 2 theta. So I have 2 theta, so it becomes 4 theta. So it becomes 2 theta becomes 4 theta. So 1 upon 8 integral 0 to pi upon 2 1 minus cos 4 theta d theta. So 1 upon 8, 1 integral is theta, cos 4 theta integral is sin 4 theta upon 4, 0 to pi by 2. So substitute 0, pi by 2, so pi by 2 minus 4 sine minus sin 4 pi by 2 by 4 minus substitute 0, 0 minus sine 0 by 4. So it becomes 1 upon 8 pi by 2 minus sine 2 pi by 4 minus 0. Sine 2 pi is 0. So just only the answer is pi upon 16. That's going to be the answer. That completes the paper. See you in the next paper.